This is a lecture over quadratic functions for Math 107, Chapter 2. Let's start by contrasting linear equations and quadratic equations. Rather, we're going to start by seeing the similarities as well as the differences between linear equations and quadratic equations. So on this side, get the pen, this will be linear equations, and these will be quadratic equations. Graphically, a linear equation graphs into a straight line. Let's just say this is the line. Right? Often we look for important points like the x-intercept, the y-intercept, and the slope. So this is the slope of the equation, the m, remember, slope of the line. Okay, and this is your x-intercept. And then, of course, there's a y-intercept up here, but let's just let that go for a minute. And for the quadratic equation, its graph is a parabola. Let's say the parabola looks, well, that was supposed to be red. Okay, looks something like that. Now, we no longer look for the slope. In fact, you have to go to calculus to find the slope. Instead, we look for certain points. We look for the vertex. That's an important point. And it's denoted by the letters H and K. H is the x value at the vertex, and K is the y value of the vertex. We also looked for x-intercepts, but now, notice there's two of them. Okay, those are your x-intercepts, and they're usually labeled x1 and x2. Doesn't matter which one you call 1 or 2. I just did it that way. Okay, so you see they're similar to this x-intercept over here for the linear equation, but in the quadratic equation you have two of them. They have another name too. Instead of x-intercept, you call them the roots. So we're interested in the vertex. We're interested in these x-axis intercepts, which we call the roots. Right. Just like the line could go up or it could go down. Let's get a straight line here. Perhaps you have a line that goes down like this. Okay, that's possible. Same with the parabola. It could go up or down. It could open in this direction, or it could open, for example, in that direction, and we're also interested in that. So we are interested in the roots, the vertex, and we're interested in whether it goes up or down. Run out of room. Up or down. Down or up. So that's a little bit of the graphing. Now let's look at the algebra. For a linear equation, I can write it in two ways. I can write it like this. Some number, ax plus by equals c. And that's a linear equation. It's linear because the x and y appear only to the first power and not multiplied together either. So ax plus by equals c. There's another way that's actually more graphing friendly, and that's y equals mx plus b. You're familiar with both forms. Both of them are equations for a line. This is your standard equation, standard form for the equation, and this I call the graphing friendly because it has certain elements of the graph already built in and you just have to read them off. In this case, for the linear equation, the m gives you the slope without doing any work, and b is the y-intercept. So that gives you a point on the curve, and it gives you the slope of the line. So you get a lot just by looking at that equation. Let's move over now and look at the quadratic equation. Here is the standard form of a quadratic equation. It has a standard form. Looks a little different. Actually, there's another form with the a's and the b's and everything on one side, but I'm going to write it like this. ax squared plus bx plus c. I'm going to call that the standard form. Like I said, there is another more standard form than this, but Let's call this the standard form, or one of the forms of the quadratic equation. It can also be written in a graphing-friendly form. And the graphing-friendly form looks like this. Y equals a x minus h squared plus k. Alright, the reason I call this graphing-friendly is because it immediately gives me information about the graph. It gives me the vertex. H and K. The H and K I want up here are coded right into the graphing-friendly form, and you get them, so to speak, for free. Just like you get the slope and the y-intercept for free when you're working with a linear equation. You can convert from one form to another. If you have the linear equation, all you have to do is isolate the y to get here, or you can rewrite things in that form. Those are easy to go back and forth. For the quadratic equation, you can FOIL out the x minus h squared and get up to here. That's by foiling. I'm right at the edge. You FOIL to get from this form back up to the other form that I'm calling the standard form. To get from the standard form down to the graphing-friendly form, you have to complete the square, which is a little more involved process. But they are equivalent, and they're just different ways of writing it, and each one has its advantage. I want to go over that graphing-friendly one a little bit. Here's the form in general. Now I want to show you how to read the information off this form, and later on I'll give you some insight as to why it works this way. Alright, the A, the sign of A tells me which direction this parabola opens. If A is greater than 0, that means its sign is positive, it opens up. If A is less than 0, then it means it opens down. So here's an equation. I just say 3 times x minus 7 squared plus 24. Right. All you have to do now is just pattern recognition. A is 3, so it opens up. If I look at this x minus h, I have x minus 7. 7 is h, and at the end the plus 24 is the k. So the vertex for this parabola is at 7 in x and 24 in y. So if this is 7 and this is 24, the vertex is here, and this is a parabola opening up. Now I don't know how it opens up from this without doing more calculations, but at least I can find this one point and know that the parabola is opening up. In this case, A is minus 2, its sign is negative, therefore this is a parabola opening down. I can read the h and k off of this, right off the equation. The h is 7, the k is negative 12. Remember, the negative sign is part of the equation. What I call h has to appear after a negative sign. This is a little bit of a tricky point. I'm going to write again the equation in general. Ooh, forgot the squared. Okay. So if I have an equation that looks like this, let's just do the same one again. And this is x, and there's a plus sign here. Right. A is still 12. A is still minus 2, I'm sorry. So it's opening down. The k is still negative 12. Nothing happened there. But you see there's a negative sign here, but you've got a positive sign here. Algebraically, you write this as x. You have to reconstruct that negative sign. If there is a negative sign here, that would work if this is a minus 7. Right? So, A is minus 2 as before, opening down. But h and k in this case, h is negative 7, k is negative 12. You don't have to write this step if you can recognize it. Let me do one more of those so you can see that again. This y equals 14 x minus 3 plus 12 squared. A is 14. It opens up. For h and k, I can read it off. X minus 3, therefore h is 3, and the k is 12. But if the equation happened to be 14x plus 3 squared plus 12, again a is 14, I keep saying that, it opens up. And the the vertex of it that I know, because of the plus sign here, h is minus 3, k is still 12. Here's a little discussion that gives some insight into how this works with the h and k. I'll start with the simplest quadratic function that I have, y equals x squared. If you plot these points out, you'll see this is a function that opens up. If I multiply by a negative sign, so I have y equals minus x squared, if you plot out some points, it opens down. You can also remember the previous chapter when we talked about reflecting about the x-axis. The negative sign, you would just multiply the function by negative, and that would reflect all the points down. So, well, this was a parabola that went like this. This one would flip over and go down. Actually, this is not a depiction of x squared. That has its vertex at the origin. In fact, why don't I draw it properly? So for y equals x squared, this is a parabola, and it opens up, and it looks basically like this. It's symmetric about the y-axis, and its vertex is 0, 0. If I multiply by minus 1, that's also parabola. Its vertex is still 0, 0, and it's opening down. It has the same shape as before. It just gets flipped about the x-axis. That's what the negative sign does. If this is multiplied by any other number, you have the same result. If I have y equals 4x squared, I end up with a parabola opening up. If I multiply by a negative number, minus 4x squared, that flips a parabola and it opens down. That gives you some insight into how a and the sign of a is used to determine whether the parabola opens up or down. It has to do with reflection about the x-axis. Now let's start again with the y equals x squared and consider a vertical translation. That means I'm just going to move the parabola without changing its shape. I'm just going to move it up or down in the plane. I do that by adding a number on the end. This is vertical translation from chapter 1. So if I add 12, that moves the whole parabola up 12. Minus 12 moves the whole parabola down. Okay. That would look with the plus 12. That's 12. You just moved it up 12. If I subtract 12, I get parabola moved down 12. Okay. This is minus 12 right here. You're just moving down 12. Right. So in general, because that's a vertical translation and I don't care what number I add onto it, I want to do that in general, then I would write y equals x squared plus k. Now you see k sitting on the end is just moving the parabola up or down. And since you started at 0, 0, this just gives you the y value of the vertex. And now look at horizontal translation. When you translate something horizontal, you have to modify the x's. And remember that it was counterintuitive. So if I write y equals x minus 7 squared plus, well, we'll use the 12 again. Well, forget that for right now. Y minus 7, that would just take the original parabola I had, this one right here, and move it 7 in that direction. Remember, if you have the negative, x minus 7 moves to the right. So that would just move the parabola over here to 7. If I had x plus 7 squared, that would move the parabola to the left. minus 7. I want to write that in general. So I write y equals x minus h squared, and h is how far you're moving it to the right. But if that's a negative number so that it becomes x plus h, you then move to the left. So when I put all this together, I get the graphing form of the equation. You can see how we used the x, the a, the h, and the k to determine the vertex of the parabola and whether the parabola opens up or down.